back once again. Today, we are going to start a new topic under elective math, for which we call it binary operation. Binary operations. Binary operation. So, if I may ask, in your own small way, how do you understand the word binary? Yes, every answer is welcome.
I think it means two.
It means two. Okay, binary means two. Very good. Okay, I believe when you started mathematics, you started dealing with some operational signs, isn't it?
Yes.
Yes.
Yeah. And these operational signs included which ones? Can you mention some of them? We had operational signs like what?
Addition.
Yes. So we have addition, subtraction, multiplication, division, and so on and so forth. Even as at now, there are other operational signs you are dealing with for which knowingly or unknowingly, you actually have to learn it by force, which includes the square root sign, the radical sign, and it's something that we just did recently. It's an operation on numbers. So when we consider what we call binary operations, then it means combining two items at the same time using the operational signs. It is only two items at a time. Two items at a time using the basic operational signs. That is all we have to know concerning binary operation. So when we talk about binary operations, it's simply the word binary means composed of two pieces. It's composed of two pieces. So binary operation simply is a rule for combining two values to create a new value. So a rule that is used to combine two values to obtain another value, we say it's a binary operation. So for instance, when I go to class 1, you bear with me that we learned that we have 1 plus 1. 1 plus 1 became a rule, and therefore it gave us another answer, which is what? 2. So 2 is another number. At one point, it was 1 minus 1, and we had what? 0. So it means you are having a rule linking you to another operation, but it is two things at the same time. So a binary operation on a set of a calculation involving two elements of the set to produce another element of the set, then we say you are dealing with binary operation. It is simply operations that combines two sets to give you another element within the set or outside the set. That is what we term as binary operations. So in binary operation, some mathematical symbols like the dot, the square with a dot, or a square alone, and some symbols like the spade, the club, the triangle, the heart, and then the diamond, as well as star, are used to represent the rule. They are used to represent the rule. Because in some binary operations, you may not see only one operational sign. For instance, in this example, we have only the addition sign in our operation. In some cases, you may have two or more operational signs coming on board, but it's just combining two items at the same time. So because you may not have one operational sign coming to represent the operation, then it means we define the binary operation with a symbol. And the symbols like the dot, the square with a dot, a square, the heart, the club, the triangle, this is the spade, sorry, then the heart, the diamond, and then the star. So, for instance, the perfect example may be I have an element A operating, so I'm using star on B to give me an expression which is A plus B minus AB. Now, this becomes a rule for the operational sign. Now, how many operational signs do you see in this expression that I've written here?
2.
Okay, so you can see 2. Yes, any other person? How many can you also see? Okay, so you said 2. Can you mention the operational signs you can see? Yes, it includes what operational signs? We have what? Okay, so you let me help you out. I think your network is not good enough, but we have the addition sign, we have the subtraction sign, which you can see here, and we equally have the multiplication sign connecting these two. So it is not 2, they are 3. The operational signs are 3 in this rule. But at the end of the day, how many elements am I combining? I'm combining only 2 elements, which are A and B, using the operational sign star or the binary operational sign star. So we say star is defined by the rule A plus B minus AB. Remember that for every binary operation, there's a rule that defines the operation, but you are combining 2 elements at a time using that operation. Let me take another rule. Let's assume that I have A triangle B, and this A triangle B is giving us 2AB divided by A plus B. How many operational signs can you see in this rule?
3.
We have 3. So can you name them? So we have 3 operational signs. But what are they? We have what?
The addition.
What else? Multiplication sign, as well as the division sign. Thank you. So these are the operational signs that define the binary operation triangle. So binary operation is so simple because in most of our calculation activities, you realize that we come along with different operational signs coming together to give you another expression. And interestingly, we are going to deal with the real number system. The real number system, and you've learned about real number system already. And real number system includes integers, it includes rational numbers, it includes whole numbers, and then counting numbers. So we are going to use the real number system to operate on 2 items at a time. So if we move forward, example of a binary operation is A diamond B, which is equal to 2AB minus A. So we have A diamond B, which is equal to 2AB minus A. Yes, so that is my last example. Then we will start working on how to operate using the binary operation rules. How many operational signs do we have in our rule? We have 2 operational signs, which are the multiplication sign and the subtraction sign. They are the operational signs that we have over there. Okay, so let's move forward to the next slide. So now we are taking one first work example. A binary operation is defined on the set of rational numbers Q as follows. So we've been given A star B equal to A plus B plus 2AB. So the rule for the binary operation is A star B equal to A plus B plus 2AB. Now we are to evaluate these operations here using the rule. We are to evaluate these operations here. We have I, and I. So taking the first example, which is A, the rule being A star B equal to A plus B plus 2AB, then considering question I, which has the numbers as 3 star 7, when we compare 3 star 7 to the rule A star B, then it means that the A in the rule is being represented by what number in the expression?
3.
3. And then it means automatically B goes for 7. So it's all about substitution in this sense. So it means we are going to have 3 plus 7 plus 2 times 3 times 7. Then simplifying, we work the ones in the bracket first, but we can also add 3 and 7. That gives me 10 plus 2 times 3, 7. We have what? 21. Then 2 times 21 will give us 42 plus 10. Therefore, the final answer is what?
52.
52. Thank you. So it means when we operate 3 star 7 with a rule, it gives us an answer of 52. And 52 is also part of the rational number system. Let's go to the next example. The next example, which is II, we have 5 star 4 star 2. But this time, how many elements are we working with? So we have 3 elements we are working with. So because with respect to binary operation, we are dealing with 2 items at a time, then in this situation, what it means is that we are not going to use all the 3 elements at the same time, but we use them 2 at a time. So in this case, it is better to use the idea of board math by working with the one in the bracket first. So we are going to have our rule as A star B equal to A plus B plus 2AB. We are still using the same rule. So considering the bracket, which is 5 star 4, yes, that is going to give us, comparing the 5 star 4 to A star B, then it means our A value is 5. So we have 5 plus 4 plus 2 times 5 times 4. When we simplify, we are getting here as 9 plus 2 times 9. And 2 times 9 is 18 plus 9. And 18 plus 9 gives us an answer of what?
27.
27. So we've worked out what is in the bracket. So it means that now we have 27 star 2. And still we have to use the rule. So using the rule, it's going to be 27 plus 2 plus 2 times 27 times 2. So when we simplify, 27 plus 2 gives us an answer of 29. Then plus 2 times 27 times 2. We have 2, 7, 14, and 2, 4. 2 times 2 is also 4, plus the carry of 1, we have 54. Then now we can have our 29, and 2 times 54, 2 times 4 gives us an answer of 8, and 2 times 5 gives us an answer of 10. So putting the two together, 29 plus 108, what answer do we have?
137.
137. 137. So this implies that our operation combining 3 elements, which is 5 star 4 star 2, gives us an answer of 137.
Please, the 5 times 4, you roll 9 instead of 20.
The 5
Times 4.
Oh, sorry. Let's go back. Sorry. So that is 20. Thank you for the correction. So we have 20 here, and 20 times, then it means we have to go back and do everything all over again. But I believe you follow what I'm doing.
Yes.
Good. Thanks for the correction. So we have 20 times 2 giving us 40. So we have 49 here. And then coming to this side, let me correct everything here. So that is giving us 49 star 2. So that will be giving us 49 plus 2, then plus 2 times 49 times 2. And that will be giving us 49 plus 2, that is 51. Good. And then plus 2 times 2, 9, we have 18. 2 times 4, which is 8, plus the 1, giving us 9. I believe that is right. And then 51 plus 2, 8, 16. 2, 9, 18 plus 1, 17. So when you put it together, please, what are you getting?
227.
So we have 227. So it implies that R5 star 4 star 2 gives us an answer of 227. Thanks so much for the correction. This is the question we are going to work on, which is our last question. Then you do some work examples for me. So considering the same rule, which is A star B equal to A plus B plus 2AB. That's the rule we are supposed to use. Then having half star 3 on 4, that will be equal to the value of A is actually half plus the value of B, which is 3 on 4, plus 2 times the value of A, which is still half, times the value of B, which is 3 on 4. Have I done the right substitution? Okay, so having half maintained plus 3 on 4 also maintained plus 2 times, when we multiply half by 3/4, that is going to give us an answer of 3 on 8. I believe I'm right. So we still have half plus 3 on 4. And when we multiply 2 by 3 on 8, 2 will go into 8 4 times. So we are going to be left with 3 on 4. Please, are we clear with what I've done here? So at this moment, how do we put them together?
LCM.
So we find the LCM. Very good. So finding the LCM, LCM for 2, 4, and 4 is actually 4. 2 goes into 4 2 times, multiplying 1, we have 2. 4 goes into itself 1, multiplying 3, we have 3. Then 4 goes into itself 1, multiplying 3, we still have 3. So adding up the numerator, we are going to get 3 plus 3, which is 6, plus 2, giving us actually 8 on 4. 8 on 4 gives us a final answer of what?
2.
Thank you. So in other words, the binary operation defined by A plus B plus 2AB on half star 3/4 gives us an answer of 2. Any question, please, based on what we've done so far? Okay, if there is no question, then I believe we can move on to the next slide. So from the next slide, this is what we have. We are graduating from one level to the other. So we have a binary operation giving us A dot B equal to A squared minus 2AB, where A and B are members of R, where the R here means they are members of the real number system. They are part of the real number system. So use this rule to find the solution for A dot 5, all dot 5 dot 3. Sorry, so 3.5, all dot 5.3. I want you to give it a try and give me an answer. I'm giving you 2 minutes to get that done.
Okay, so what answer did you obtain?
Okay, so let's do it together. Now, with this question, as we learned early on, dealing with binary operation, then it means 2 elements or 2 entries needs to work at a time. So first, we need to consider the first parenthesis, which we have 3.5. And given the rule to be A squared minus 2AB, then it means we are going to get 3 all squared minus 2 times 3 times 5. When we simplify that, we are going to get 3 squared, which is 9, minus 2 times 3 times 5, which is 15. So 2 times 15 gives us an answer of negative what?
30.
Negative 30. Then we have our 9 repeating itself. So 9 minus 30 gives us an answer of what?
Negative 21.
So negative 21. So we've operated in the first parenthesis. Now we go to the other one, which is 5.3. Using the same rule, then that is going to be, this time around, a value is 5 all squared minus 2 times 5 times 3, because the b value is 3. When we simplify, we'll have 25 minus 2 times 5 times 3, which is also 15. And then we have 25 minus 2 times 15, that is the answer, 30. So 25 minus 30, what value are we getting?
Minus 5.
Minus 5. So now, coming to our final part of the statement, which is 3.5 or .5.3, we know that 3.5 gave us an answer of negative 21.
Negative 21.
And then 5.3 gave us an answer of negative 5. So we are now going to operate on these two using the same rule. So that is going to be giving us negative 21 all squared minus 2 into brackets negative 21 times negative 5. Please, does it make sense?
Yes, please.
All right, so negative 21 all squared. What answer does it give us? You can do your side work and then just put your value there. So you have 21, another 21. 1 times 1 is 1, 1 times 2 is 2, 2 times 1 is 2, 2 times 2 is actually 4. So we have 1, 4, and then 4. So negative 21 all squared is giving us 4, 4, 1. Minus 2 into brackets, 21 times 5. So you can also do it as side work. 21 times 5. We have 5, 1, 5. 5, 2, we have 10. So that is giving us 105. It should be a positive number. So we have 105. Then finally, 441 minus 2 times 105. 2 times 5 is 10. 2 times 0 is 0, plus the 1, which is 1. Then 2 times 1 is 2. Then finally, we have to subtract 210 from 441. Please, what answer are you getting? You can also do it side work. 441 minus 210. But get me the answer.
$231.
So 231. So operating on this implies that 3.5 or .5.3 based on the operational sign gives us a final answer of 231. Any question before I move on to the next slide? Any question, please, before I move on to the next slide? Okay. But I believe you've understood what we are doing. Binary operation. Binary operation.
Yes, please.
Okay, so just going back, some started with us, others did not. So in a very simple way, when someone asks you what binary operation is, what will you actually tell the person?
I'll say it's I won't say adding, but is combining two different elements to create one element.
Thank you. Okay, so thanks so much. As you have simplified the whole statement, it's just combining two elements at the same time to obtain another element. Then you can go further to say that in this case, we have some operational signs we work with. Combine the two elements, you don't only consider one operational sign. Therefore, we have symbols that we use to represent operations when it comes to binary operation. We have symbols like triangle, star, dots, squares, diamond, clap, any other symbol altogether. But we use the basic operational signs to define those symbols. And in this case, for every binary operation, it has a rule that defines the operation. It has a rule that defines the operation. I believe adding this refreshes each and everyone's mind about what binary operation is all about. Please, are we all clear?
Yes, please.
All right, thank you so much. Now let's move forward. Then we are moving on to how to find the true set under a given binary operation. How to find the true set under a given binary operation. Now, in this case, then it means how are they going to frame the statement whereby they will ask you to find the true set. Now, let me go back a little to primary school. In primary school, around primary 5, primary 6, we learn something like this: 2 plus 3. And then they will say this is equal to box, isn't it? I believe this was in class 1. I always like going to class 1. So in other words, what then is the answer for box? You are filling in the blank spaces. What then is the answer for box?
5.
So the answer for box is actually 5. Good. So this time around, when it comes to finding the true set in a particular binary operation, then this time around, it means you know the operation, the rule for the binary operation, and you know some elements as well as the solution, but you don't know others. Therefore, you are finding the missing element. So coming back to JHS, then you may have a question like x plus 2 is equal to actually 5. Therefore, find the value of x that satisfies this. So then you go ahead and say that then x plus 2 equal to 5. Finding the value of x will be equal to 5 minus 2. And the value of x gives us what? 3. So this is it. Then since they say find the value of x, then the answer is x is equal to 3. And that's the only solution that satisfies the equation. But if they say find the true set, then it means your solution you've obtained must be written in the set notation. So you can just introduce your curly bracket and say that x is such that x is equal to the number 3. Then it means that is the true set. That is the true set. So the same thing comes to binary operation. You may know the rule, you may know some of the elements, and you have to find a missing element. You may know the rule, and then you may know some of the elements for the rule, but you are supposed to find the other missing elements. And it all boils down to substitution method that can help you find the missing elements. So we have one example here which says that a binary operation is defined on the set of rational numbers Q. A star B equal to A plus B plus 2AB. Find the value of Z if Z star 3 is equal to 9. If Z star 3 is equal to 9. So in other words, we are finding the value of Z from this operation. So knowing our rule to be A star B equal to A plus A 2A plus B plus 2AB, then finding the value for Z in the equation Z star 3 equal to 9, then it means we can use the rule to define Z star 3. And defining Z star 3, A represents Z in the operation, and the B represents 3 in the operation. So it's all about substitution once again. So Z star 3 is going to give us Z plus 3 plus 2AB equal to, sorry, let me substitute them. Let me go back and substitute them. So plus 2 times z times 3. And all must be equal to the number 9. Simplifying the left-hand side, we are going to have z plus 3 plus 2 times 3z all equal to 9. We are getting something like algebraic equation to solve. So continuing from this side, we are going to get z plus 3 plus 6z equal to 9. Now they are like terms. And what are the like terms you can see on the left-hand side?
6z plus and z.
And that is giving us an answer of what?
7z.
So we have 7z. And this must be equal to 9 minus 3. So we have 7z is equal to 9 minus 3 gives us an answer of 6. Then you divide both sides by z. Sorry, by 7. And then z will give us an answer of 6 on 7. Therefore, the value of z that we are looking for is 6 on 7. The value of z that we are looking for is 6 on 7. Please, is it clear?
Yes, please.
All right. Okay. So if that is well understood, then it means we can take another example. But you are going to work out these examples for me. I'm giving you enough time to work out these examples. So we have some work examples here. Suppose A star B is equal to 3A plus 2B. Find the value of square root of 3 star square root of 2. We've tested it, so I believe you know how to go about it. And then question number 3 says that if A star B is defined as that, solve the equations as you can see there. So we have A star 3 equal to 19. That's one equation that you are solving. And the other equation is A star 3 plus 2 star A equal to 4M. So you have to solve for this equation as well. So that's another equation altogether. Then question number 4 says that the operation star is defined on the set of real numbers by M star n equal to m minus n all over n, where n is not equal to 0. Now, let me explain this concept here. When you have any rational function given to you and they say where n is not equal to 0 per this example, what it means is that when the value of n is 0, it means this function does not exist. That is why we say that where n is not equal to 0. So there is no way they will give you an expression whereby n will be 0, because you may not get a solution for that matter. So you are going to take this ones as your assignment, but you are going to work out question number 4 for me. So I'm giving you a maximum time of 8 minutes to finish this whole work for me. Please, are we all clear? Start work. All right, so time is up. Okay, so let's discuss the solution you've actually obtained. So having the binary operation rule defined as m star n equal to m minus n all divided by n, where n is not equal to 0. A, evaluate 3 star 5 star 2. Okay, so all that we expected you to do, having the rule as m star n equal to m minus n all over n, then considering first 5 star 2 that will be giving us 5 minus 2 all over 2. And that will give us an answer of 3 on 2. Then now we combine 3 star the solution for 3 on 2. So we use the same rule, and that is going to be 3 minus 3 on 2 all over 3 on 2. Simplifying the numerator, 3 minus 3 on 2, LCM is 2. This is over 1. So it means we are going to get 1 goes into 2, 2 times 3, giving us 6. Minus 2 goes into itself 1. Multiplying 3, that will give us 3. So the final answer here is giving us 3 on 2. So the numerator is 3 on 2. And the denominator is also 3 on 2. So when you divide 2 3 on 2s, it gives you an answer of 1. So it tells you that when you operate 3 star into brackets 5 star 2, you get an answer of 1. You get an answer of 1. Now going to the B, using the same rule, let me take the I. Our time is up, but let me try and then do the I with you so that you compare it with your solution. So the rule still holds as M star N is equal to M minus N all over N. So having 8 star K, when we simplify that, that is going to give me 8 minus K all over K. And considering the right-hand side, having 12 star 3, that will give me 12 minus 3 all over 3. And 12 minus 3 is an answer of 9 divided by 3, giving us 3. So it means we are equating the two statements, which is 8 minus K all over K should be equal to the 2 star 3, which is giving us an answer of 3. Doing away with fractions, we have 8 minus K equal to 3 times K, which is 3K. Grouping terms, we are going to get 8 equal to 3K plus K. And we will be having 4K equal to 8. Dividing both sides by 4, then K is going to give you an answer of 2. So I don't know how many of you had the answer for K for the first one as 2. Yes, how many of you had it? How many of you had it? Okay, so if you did not get it as well, unfortunately, our time is up. So kindly copy this down, or you can screenshot the whole screen and then go back and review the whole lesson. Review the whole lesson. Now, going back to the previous screen, I left question 1 and question 3 for you to try your hands on them. Kindly do that. We are going to meet, God willing, tomorrow and tomorrow next to go through more of these questions. Thank you so much for joining the call. It's a great privilege teaching you. You can inbox me when you have some basic challenges so that I can attend to them. It's my major concern that you understand whatever you are learning. So thanks so much, and then God bless you and have a good day. Bye-bye.
Bye.